Yep, I'm in the shed. I'm setting up a very simple experiment here. I'm at the tripod here. I'm 3 right in the colour grid and only 2 down in darkness because I'm in the shed, and even though it's a bright day, there's no actual shadows on the ground, so that's my modus operandi, mode of thinking sort of thing. Now we're going to do a very simple experiment here, because we know we can get the organism to grow if we get a bit of chicken, white meat or something in the water with our polystyrene in our. We can do it with molybdenum. We can do it with zinc. We can do it with molybdenum. We can do it with zinc metal, lead metal down the bottom. As we've determined. I just got to find my little container things. Yeah, I've got my little scoops and stuff. There's another one down there somewhere. I can find it. Yep, there we go. This is the one I want, I think. One for different containers, you see. So the idea is very simple. We're going to replace the zinc oxide with a candle, which sounds far-fetched, I know, but let's see how we go. We need to put a little thing on the end here, I think. Anyway, I'm just going to pour them down, and hopefully it should. If we've got it, we can just tap it. And we can just sort of put this down and slowly but surely draw our plans against ourselves. Yeah, because I've just washed the container, so it's a little bit sticky. Yeah, this is one I prepared before, sort of thing. I've got a better idea. Since we are going to put the candle in there, why don't we let's check it out first. We can actually put the candle down, like that. Well, that idea about having a pillar in front of an entrance. So yeah, I hope you're measuring this. No, it's a 2.4 litre milk bottle, and these are about 3 to 4 mil pullings. Not quite half a centimetre or something. I think it's 4.5 mil or something is the maximum, but I can get my micrometer out. But as we learnt before, in all the others, large chunky pieces of polystyrene better than fines. All that grading and grating we did, that was wrong, because we didn't know about polystyrene generating reductive flammable gas when it's wet. So there's your. So what's this idea about CPs don't like waterlogging, and what do they mean by waterlogging? I think that's what they mean is when you cut down a forest, you log a forest, the water table comes to the surface. Now, there we go. I think we finished it. Put it back in a container, sort of thing. And the idea is to take this candle, and all we do is stick this down in there. That's all we do, down in there. Now, these candles, I definitely know if I get it onto spot cutting. These Easy Light brand of candles, Easy Light, these definitely do, these quite white candles, whether they got titanium oxide in it, dioxide. We know that the titanium dioxide does actually grow the red organism. It's just as good as zinc oxide in a way. So what do these two oxides do? That's what you probably want to ask the question. So we know that the ones that they take copper out of the water, because you can actually see copper sulfate being attached. The candle will actually blue, it will take the copper out of the water, so we know that it will take any copper that's in the water out of the water. We also know that the paraffin candle wax can act a bit like the aluminium and cut out the H2S reaction, which I think is what the zinc and the titanium and probably the cerium is probably doing. So we'll have to see, but anyway, we'll see. Anyway, now what we do is then I take my my piece of meat, and I may need to get my pair of trusty rusty scissors to cut it in half. So this is basically chicken breast, which is a white meat, so it's supposed to be low in iron sort of thing. So apparently CPs don't like iron, don't know why that is. Probably because it likes to rust, oxidise up, and when it does that you get all this H2S reaction business. Because you know, if you're forming iron oxide, what's happening to the sulphur if it's an iron sulphate or something? So you've got to think about that. So this is what I've got to try and do anyway. Cut this up. And I will have to wash my hands afterwards, of course, because it's chicken. Anyway, so the idea is to, well, first of all, I'm going to actually add some water to this, and it'll be tap water, because if there's any copper in the tap water, the candle should take it out. Maybe instead of just giving you a blank spot, I should actually take the camera on the tripod, as you do. Yeah. Make sure we are in camera, and we fill up the container. So we've got it's a 2.4 litre container with about 150ml volume candle, basically. Or whether that's a true volume, because you never know what they do with things these days. You know, they fluff up ice cream and things like that. So for all we know, it could really only be like 50 mils or something. You don't know. Maybe they can. Anyway, so what we're going to do is we're going to put that in there basically, and that should slowly you know, go off. And if we grow the red organism, bingo, we've got it down to a very simple situation. Polystyrene, candle, or candle wax, and basically you could just use your sand or something like that, and then you can definitely get your red organism growing in the, if we can do it, get our red organism. So anyway, time to label this, I suppose, and I'll just label it candle, I suppose, and the date, I suppose. I just put candle on here or something. Oops, I have to put a bit of water. I think I need to put the lid on first to do this. Anyway. Okay. It was just a short experiment. It's you know, a qualitative one, yes or no sort of thing. So I just put candle in here. It's a full candle, and I'll put the date, hang on, it's the 25th on Monday, 24th, 23, 22, 21, it's 2019, 18th today. That's okay, so it's the 18th, I believe, yeah, 18th, Monday so that's Monday the 18th of December 2007. We don't really put that because it's on the video. Anyway, I just stick it there and put the lid off now so it's exposed to the air, and I'll make sure the water level's up there, and go from there and see what happens. It might pink faster than we think, because I know when I try things like toothpaste, I did some really crazy thing with toothpaste and aquatic utricularia. It was 1 ml of toothpaste in a 2.4 litre container, and it actually caused utricularia vulgaris to redden up in about a week or so, and it went that really nice magenta purpley sort of thing. You might want to retry that yourself with it was just you know, the usual Colgate toothpaste stuff, none of this, the basic one, the original one, none of this fancy stuff they have, you know, 5 different functions, you know, and barely any of them actually work. Yeah, it's my sarcasm going through there. Okay, my cynicism and my sarcasm. Okay, I think this is about over and out for this one. See you on the other side of this. Something happens, okay? From day 96 or 97 Antics. Okay, see ya.